We're going to look at some applications of normal distribution. Okay, so the amount of instant porridge oats in a packets packeted by a particular machine is normally distributed with a mean of grams and a standard deviation of 6 grams. The advertised weight of a packet is 500 grams. So A, find the portion of packets that will be underweight. So it will be less than 500 grams if the mean is equal to 505. So using our normal distribution, we have the lower to be infinity, and then we want to stop it at 500. Our mean here is 505. Whoops, wrong one. Our sigma is 6, and our mean here is 505. So then we have 0.2023. So A of x being less than 500, which is then 0.223. B, find the value of mu required to ensure that only 1% of packets are underweight. So we want probability where x is less than 500 to be 1%, so 0.01. Now, we can't normally do that without finding what mean is. So if you remember the previous part, we need to use the inverse. So we need to find out what the mean is. So that means we need to convert it to a z value. So we need to find the z value so that we have 0.01. Inverse normal. Whoops. Probably don't want this one. So find the inverse normal using interactive. We need to start from the left. We're going up to 0.01 because we want 1%. Our mean for a standard normal distribution is 0, and our standard deviation is 1. So z is negative 2.3263. Putting that into our conversion, we want x to be 500 minus the mean over our standard deviation, which is 6. We can then solve for our mean. So then our mean is going to be 500 minus 6 times negative 2.3263. 500 minus 6 times negative 2.3263, which is 500. I just keep switching. 513.9578. As a check on the setting of a machine, a random sample of 5 boxes is chosen and the setting is changed if more than one of them is underweight. Find the probability that the setting on the machine is changed when our mean is equal to 505 grams. So, because we want more than one of them being overweight. That means it's also the same as 1 minus the probability of less than 2 of them being underweight. So we want 1 or less, in other words. Now, if you think about it, we're picking boxes that are either going to be underweight or they're not going to be underweight. So then this is actually just a binomial distribution. With the binomial distribution, we have we have 5 different boxes to choose from. So interactive, and this is discrete because it's binomial, and it's continuous because we want less than 1. So we'll need to think about what numbers we're putting in. We want 0 to 1 because we either have no boxes or 1 box. So 0, upper limit is 1, number of trials we have 5, and then the probability of success we worked out earlier in part A, because it's 505 for the mean, so that's 0.2023. That then gives us 1 minus 0.7326. Just remember, alternatively, we can just do 1 to 5 as well. Anyway, if we subtract that, we get 0.2674.